In 5.2, we're going to talk about solving a system of equation by substitution. Last section, we focused on solving a system of equations by graphing. And again, our goal is to take two equations with two unknowns, normally x and y, and try and figure out and solve for the values of x and y that would make both equations true. Through graphing, we found that by plotting points from our two lines and figuring out where the point of intersection would be for those two lines. So today we're going to learn a second process. This does not involve graphing, but is more of an algebraic approach to solving a system of equations. So what we're going to learn about is the process of substitution. So substitution in general means to replace. So like if you think about a sporting event like basketball and you're going to substitute in for somebody, what you are doing is you're going in for a position that another player is currently in, and you guys are going to simply replace each other. Now the key idea when you substitute is that normally you're going to substitute one person for another at an identical position. So for example, let's say it's the game of football and your quarterback gets injured. Well, you're going to replace your quarterback with another quarterback. You're probably not going to replace your quarterback with a lineman. So you're always going to replace things that are equal. When we substitute in, essentially what we're going to do, let's say we have a very simple system of equations of 2x plus 4, and we are told that x equals 3. What it literally means to substitute is we're going to take the value that we know. We know that x equals 3, and we're going to take that value and we're going to replace it in our equation for the value it's equal to. In this case, it says x is equal to 3, so we're going to take 3 and plug it in where x goes. So we're taking the x out and putting the 3 in instead. Now, when we do that, we're going to make sure we hold all the mathematical operations the same. So 2x literally means 2 times x, and then the plus 4. So when I plug in the 3 and replace it and substitute it, I'm going to take 2 times 3, and then I'm going to add 4. And that then would simplify down. I would have 6 plus 4, which would give me 10. So that's a process of substituting by replacing. Now, what we're going to do is we are going to substitute a system of equations. So instead of just giving you an answer like, hey, x equals 3 and plugging that in, instead what you're going to get is an expression. So our goal is to do the same thing. Now it's going to be a little bit tricky, but our expression literally says, if you look at the second one, it says, hey, y is equal to 2x plus 1. Well, this equation literally tells me that y is equal to this right here, 2x plus 1. So this chunk, this expression, 2x plus 1, I can literally substitute that in to my other equation where I see y. If I just take out that y and plug that chunk into where y belongs, I've now substituted and then I can solve. So our goal is to try and solve through substitution. So when we do this, we're going to follow some steps. We're going to make sure that one of our equations within our system is going to be solved for one of the variables. What I want to see when saying this is I want to see an equation that says either y equals something or x equals something. This something could be a number or it could be an expression. What I mean by that is it could be y equals 3, for example, or it could say something like x plus 1. Okay, it could say anything. But our goal is we're going to make sure we have one of our equations that is solved for one of the variables. We're then going to take that equation and substitute it into the other one for the variable that it's equal to. And then lastly, we're going to substitute whatever answer we get. We're going to get a value. We're going to plug that value back in to figure out what the second unknown would be. So these are the steps we're going to follow to help it make more sense. Let's go through our examples. So here I have y equals negative 2x minus 9 and 6x minus 5y equals negative 19. So first thing we'll look for is, do I have an equation that says x equals or y equals? So you'll notice here the first equation says y equals negative 2x minus 9. So what that means is I'm going to take this chunk right here. It's an expression. And because it says y equals, I can take that expression and plug it into my second equation where I see y. I'm going to substitute that in. Now, when I do that, everything else in that equation, so I have 6x, that would say there minus 5. When I see 5y, what that means is I'm multiplying 5 times whatever y is. Now, I know from the first equation that y is negative 2x minus 9. So I'm going to take that expression again of negative 2x minus 9, and I'm plugging that in where y goes. and that's then going to equal negative 19. So what I did is I took one expression and plugged it in for the variable it's equal to into the second equation. Now by doing that, you'll notice that I have a long, sassy equation, okay? But that long, sassy equation has an x and has an x. You'll notice that there is no y anymore in this equation. So what that means is that I can take what's left behind and I can solve for x. Now what I have to do is kind of clean this up a little bit. 6x minus 5 times all that. First thing I probably want to do is take that 5 and distribute it. So I would have your 6x negative 5 or minus 5 times negative 2 would give me positive 10x. Then I have minus 5 and minus 9 would give me a positive 45. And that's going to equal negative 19. The next thing I'm going to do is combine my like terms. So 6x and 10x I can combine to get 16x plus 45 equals negative 19. And then now that I have all my x's gathered, I clean this up. Now I can do my inverse operations. So here I'm going to subtract 45 first. Whoopsies. And that's going to, again, cancel it on the left side, and on the right side, that's going to simplify down to negative 64. I'm then going to bring down my 16x, and then lastly, when I divide both sides by 16, I'm going to get x equals negative 4. So by doing that, I have now figured out and solved for x. So by substituting in that expression for y, it allows me to solve for the other variable x. Now here's the neat thing. Now that I know what x is, now I can figure out what y is. Go back to my original equation. It said y equals negative 2x minus 9. Well, I now know that x is negative 4. So what I can do is take, okay, x equals negative 4, and I can plug that in where x goes. And what I'm going to plug in is just the value, negative 4. So by doing that, here's what I would get. I would have y equals negative 2. Now, negative 2x means I'm multiplying. So I'm going to do negative 2 times the value of negative 4, which I have for x. And then at the end, I'll subtract 9. Now, simplifying this, I would have negative 2 times negative 4, which would give me positive 8 minus 9 will tell me then that y equals negative 1. So in the end, I'm going to get x equals negative 4 and y equals negative 1. And that would be my two values for x and y that would make these equations true. Now, if we go back to what this means, think back from section 1, when we graphed the lines, we found the point where the two lines intersected. Well, in this case, when we find the value of x and y, those put together represent a point of negative 4, negative 1. My x value paired with my y value. This point would be the point where those two lines would intersect. And that point of x and y represents my solution. So again, what I did here is I plugged one expression in for the other. I then solved for one of my variables, in this case x. Whatever I got, then I plugged it back into my first equation, and I solved for the second variable y. And in the end, that gives me that point of intersection of negative 4, negative 1. Okay, second example, similar to the first one, we have y equals negative x plus 3 and 3y plus 5x equals negative 1. So my first equation, notice it says y equals negative x plus 3. So we are going to take this expression. That expression is what y is equal to, and now we're going to plug it in to the second equation where I see y. So substitute means I'm going to take out the y and plug in the expression that it's equal to, so it would look like this. It'd be 3. Now, times, because 3y means times, negative x plus 3 plus 5x equals negative 1. So I plug it in where y once was. Y was right here, and now I plug that in. Now what I can do is simplify this. I would multiply here, distribute that 3, so I'd have negative 3x plus 9, and then the rest plus 5x equals negative 1. I have some x's I can gather, so negative 3 and positive 5 would give me 2x plus 9 equals negative 1. And now I'm left with inverse operations. So solving, I'd want to subtract 9 from both sides. It would cancel and give me negative 10 on the right side. So I get 2x equals negative 10. So dividing both sides by 2, I would get x equals negative 5. So there is my solution, or my answer for x. But I have two unknowns, x and y, so my goal is also to figure out what y is. So once I know what x is, I'm going to go back to my original equation, y equals negative x plus 3. This equation literally says that y is equal to negative x plus 3. I now know what x is. I now know, based on what I just solved, that x is negative 5. So here's what I'm going to do. I'm going to take that negative 5, and I'm going to plug that in where x goes. So I would have here y equals negative, I'm going to put parentheses around this because it's a little tricky. I'm going to have negative 5 plus 3. Okay. Now, the reason why I put parentheses around here is notice that it says negative x. That essentially means you can think of it two ways, like the opposite of x, or you can think of that as negative 1x, which means it would be negative 1 times whatever x is. So if x is negative 5, that means negative 1 times negative 5 would give me positive 5 plus 3. And then y plus, or 5 plus 3, I'm sorry, would give me 8. So my solution here would be y equals 8. So as a complete solution, what I would get is x equals negative 5 and y equals 8. So I would write that as a point of negative 5, where x goes, and 8. And again, if I were to graph these two lines, that is going to be the point where those two lines intersect. Our last two examples here for solving, we're going to go through an example in which we don't see y equals. Now, the first two examples I went through both said y equals. Know that I could give you a situation where we have x equals. Same thing, you'd plug in for x. In this problem you don't have an equation that says x equals or y equals. Now, what that means is that we're going to have to take one of these equations. In order to substitute it in, we need to know either what x equals, or we need to know what y equals. We need an equation that says x equals or y equals in order to substitute. If they don't say x equals or y equals, then that means we have to make them say that. So how do we do that? Well, what that means, if I wanted to say x equals or y equals, is I have to reorganize my equation. So for example, I'll take the first one. Now I'm going to choose the first one on purpose because it says negative x plus y equals 3. I'm going to do this because I see that in front of x and y, they don't have a number, which means that when I move things around, I don't have to do any division. But when I move things around, what I'm going to have to do is I'm going to have to take one of these variables, x or y, and move it to the other side. To do that, I'm going to move the x. Because it says minus x, to move that, what I would do is the opposite. So I would here add x from the left side to the right side. That would cause it to cancel. And on the right side, I would have 3 plus x. And I can leave it written like that. Now, why that's nice is because now I know, hey, I got y equals 3 plus x. I now know what y equals. Okay? So now, what do I do with that? Well, I took my first equation and I rewrote it as y equals 3 plus x. Now what I can do is I can take that and plug it into my second equation where I see y. So I'm still going to substitute or replace where I see y, but I'm going to do that in the second equation. I do not want to take this and put it into the same equation I just wrote. Bad things would happen. Okay? So I'm going to plug it into my second equation. I'm plugging in right here. To do that, I would have here 3x plus, now instead of y, I'm going to write 3 plus x. If you want to, you can get used to putting parentheses around that. Now in this case, since there is no number in front of y, no coefficient, it doesn't really make a difference. Now it would make a difference, however, if that was a minus sign. Now we can think, if we want to follow the same process, there is technically a 1 in front. So if I were to distribute that 1, it's not going to change anything. I'll have 3x. And then here I would have 1 times 3 is 3. 1 times x would be 1x. And that would equal negative 1 then. So now simplifying like I did before, gather my x's. I have all the x's on the left side. So 3x and 1x would give me 4x. Plus 3 would equal negative 1. So now here when I subtract 3, doing my inverse operations, I'll get 4x equals negative 4. Then dividing both sides by 4, I'll get x equals negative 1. So there again, I solved for x by plugging in and substituting in, for y. And now I know what x is. Now I can solve for y. Now I have many options here. Here's what I'm going to do. I can take this x, this negative 1, and I can plug it in here. I could plug it in. I could plug it anywhere where I see x. Now I'm going to be smart about what I did. Here's what I did. My first part of this problem, I took the first equation and rewrote it from negative x plus y equals 3 to 3 plus x. Well, if this equation again says y equals 3 plus whatever x is, well, hey, don't I now know what x is? So why can't I use this equation that I developed? Well, I can. So when I solve for y, I'm just going to take that x and plug it into that part right there, 3 plus negative 1. And now I know, hey, y equals, in this case, 2. Boom. Tough acting, tenactin, babes. I now know what y is. Y is going to be equal to 2. So as a point again, this would be negative 1 comma 2. And I'll go again, goes back to graphing, where that would be the point where these two lines intersect, my value of x and y. All right, last real example of substitution here. And I have x minus y equals negative 4 and 2x plus y equals 4. So again, what I have to do is get my equation to say either x equals or to say y equals. I'll notice my first equation says x minus y equals negative 4. So it doesn't look like that. Same thing in the second equation, which again means I'm going to have to reorganize things. Now, I can reorganize both equations however I want to. I'm going to look for the easy way. So I'm going to do like in the last one. I see x minus y equals negative 4 here. This one looks kind of easy because there's no numbers in front. So if I think ahead, I don't have to divide. So I'm going to take x minus y equals negative 4, and I'm going to reorganize this. Now, when I look at x and y, which one's easier to solve for? Well, when I look at this, I see that x is easier to solve for. Because it says minus y, it's easier for me. It's going to look nicer if I were to just add y to the other side. So what that's going to give me is x equals negative 4 plus y. Now, I could write y minus 4 as well. It doesn't matter. Now, where this is a little bit different is, hey, now this equation says x equals. Now, I haven't gone through an example where x equals some expression, but now we have it. So think about what we did in all the other problems. I figured out what y equals, and I substituted in. Now I know what x equals. So where am I going to substitute this one in? I'm going to substitute it in for x. So whatever I know, x equals, y equals, I'm plugging it in for that variable. So this expression of negative 4 plus y is going to go right there. So it'd be 2. Now, 2x means I'm multiplying. So I'm going to take negative 4 plus y and plug it in right there. Then I would have plus y equals 4. And notice now I have an equation that just has y in it. So to simplify, I would distribute that 2 and get negative 8 plus 2y, and then plus y equals 4. I have 2y and y, so those would give me 3y. I have negative 8. And then equals 4. And now I can do my inverse operation. So here I would add 8 to both sides, and I would get 3y equals 12. And lastly, divide both sides by 3, and now I get y equals 4. And there is my solution, at least right now, for y. Now, just like we did, if now that I know what y is, guess what? I can now find what x is. Ruh-roh. Now, where do I plug this into? What do I do? Well, I can plug this in anywhere where I see y. So I could plug it in here. I could plug it in there. Or I could use my equation right here that I wrote for x. I wrote that x equals negative 4 plus y. So why not use that equation? I know that x equals negative 4 plus whatever y is. And from my last part there, I figured out that y is equal to 4. So I can do negative 4 plus 4. And again, that's what y is. Now, solving negative 4 plus 4 is 0, so I get x equals 0. Now, real quick, don't freak out here. 0 is a number. It's between negative 1 and 1. So 0 is an answer. So some people sometimes like to say that, hey, no solution because I got 0. I don't have any cats sitting here at home. So 0 is a number. So on my point, I would have coordinates of 0, comma, 4 as my solution. So that would be, again, where those two lines, if we were to graph them, would intersect at 0, comma, 4. So again, with these last 4 examples, solving through a system of substitution. Obviously, a little bit more algebra involved than what we would see by graphing. Graphing, obviously, we get a picture, visual of it, but in order to graph, it has to be written kind of the right way. Substitution takes a little bit more work, especially when the equations are not written the way I want to, which is going to lead us into our discussion in our next section of how to solve when equations are written in a different way. Now, our last example we're going to go through here is just a little bit of modeling problem. Again, writing equations and solving these things based on a word problem. So it says here we have a drama club that earns $1,040 from a production. A total of 64 adult tickets and 132 student tickets were sold. It says here the adult tickets cost twice as much as a student ticket. So we're going to write a system of equations first and then try and solve for the price. So I have X and Y again. We're going to think adult tickets I'll label as X, and then we'll say the student tickets are Y. Okay? So my first equation, what I would have is there's 64 adult tickets, so I'll say 64X. There's 132 student tickets, so I'll say 132Y. And all total, they made $1,040. There's my first equation. Okay? Now it says here an adult ticket costs twice as much as a student ticket. Now, how do I write that as an equation? Well, it says an adult ticket. So my adult ticket is X. So I'll say that X equals 2 times the cost of a student ticket. So 2 times the cost of a student ticket, which is Y. So what that'll simplify down to is X equals 2Y. Nice. Now, that's a little bit different looking because I don't have a adding or subtracting. But now, how do I solve this? Okay, so my first equation, I should say, equation number 1 is 64x plus 132y equals 1040. This would be my second equation. Now, again, what I'm looking for is, do I have an equation that says x equals some expression or y equals some expression? I most certainly do. I have the equation here that x equals 2y. So at this point, I'm going to take the 2y, that chunk that x is equal to. And just like we did in the previous problems, I'm going to take that expression and I'm going to plug that into the first one where I see x. So what it's going to look like is this. I would have 64, and now instead of x, it's times 2y. And I plugged in that expression where x was before. And then I'm going to add the rest. 132y equals 1040. Now I just got to solve. So to solve, I need to multiply those first. So 64 times 2y would give me 128y. Plus 132y equals 1040. Now gathering my y's together on the left side, I would have 128y, 132y would give me 260y equals 1040. And then lastly, divide both sides. I know we got a big number, 260, and I would get y equals 4. Which means that the adult ticket here would cost, or sorry, not the adult ticket, but I solved for y. That would be the student ticket. Student ticket costs $4. How much does the student ticket cost? Well, like we did before, hey, we got to substitute in. I know that the adult ticket is 2 times the student ticket. Hey, that's taking that first equation and now taking the 4 and plugging it in where y goes. So 2 times 4 would tell me that x is equal to 8. So I know that the adult ticket is $8 compared to the student ticket, which is $4. And notice again, it's twice as much like the problem stated. So in this one, we talked about solving systems equation by substitution. Again, a lot more algebra involved here, but it avoids graphing anything. So if you guys got questions, make sure you jot those down. Otherwise, we'll see you next time, and good luck on those practice. Bye now.